Hello, good morning, my dear students. Welcome to your lovely channel, Khandwal Physics. Myself, Lieutenant Duti Krishna Khandwal, lecturer in physics. Welcome to you all to my YouTube channel. So, last वीडियो में बहुत इंटरेस्टिंग टॉपिक हम डील किए थे, इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू चार्ज्ड स्फीयर्स. तो अगर मेरा ये वीडियो देखने से पहले डेफिनेटली आपको मेरा प्रीवियस वीडियो देखना पड़ेगा. सो प्रीवियस वीडियो का जो कंक्लूजन मैंने ड्रॉ किया था, जो ग्राफ मैंने लास्ट में प्लॉट किया था, वो ग्राफ इधर है. ओके, थोड़ा सा रिपीट करते हैं. सो जो स्फीयर था हमारा, स्फीयर को हम दो भाग में विभक्त किए थे. फर्स्ट वन योर होलो स्फीयर and second one your solid sphere. So hollow sphere is of two types, conducting, okay, and non-conducting, and solid sphere is again of two types, your conducting and non-conducting. So ये तीनों केस में hollow conducting, you see, hollow non-conducting एंड सॉलिड कंडक्टिंग, ये तीनों केस हमारे लिए सेम था, क्योंकि ये तीनों केस में चार्ज सरफेस में रहते हैं. चार्ज रिसाइड्स ऑन द सरफेस इन दीज थ्री केसेस. ओके, प्लीज गो थ्रू दैट वीडियो, प्लीज. इट्स माय सिंसियर रिक्वेस्ट, प्लीज वॉच माय प्रीवियस वीडियो. आई हैव एक्सप्लेन डिटेल अबाउट these three cases: hollow conducting, hollow non-conducting, and solid conducting. Okay, and the graph is over here. And in these three cases we have found electric field outside the surface. It is 1 divided by 4 pi epsilon naught q divided by r square, and E on the surface, electric field on the surface is 1 divided by 4 pi epsilon naught q by r square, and E inside it is 0. Okay, and the graph is over here in front of you itself. You see, watch this graph. It is a very interesting graph. I have explained detail in previous video. So let me repeat a little bit. So this is the sphere which may be non-conducting, or solid conducting. Okay, any one of these three types. Okay, so this is the center and this is the radius. Charge resides on the surface. Okay, so in the x-axis I have chosen the distance r, and in the y-axis I have taken electric field intensity, and we have plotted a graph between r, the distance, versus electric field intensity E. And you see, from the center up to surface it's 0, because E inside is equal to 0. Just when we reach the surface, it drastically increases to 1 divided by 4 pi epsilon naught q divided by r square. So E surface is the maximum value. Okay, electric field is maximum on the surface, and when we switch to outside of the surface, it decreases like this. E out is inversely proportional to r square, because the expression is E outside is equal to 1 divided by 4 pi epsilon naught q divided by r square. Okay, so that means this sphere behaves like a point charge for an outside point, because this expression matches with the electric field intensity due to a point charge. Electric field intensity due to a point charge is 1 divided by 4 pi epsilon naught q divided by r square. That's the reason for which this hollow non-conducting, and solid conducting charged spheres behave like a point charge for an outside point. So this is the important conclusion we have drawn in the previous video. Okay, let me erase. We will now deal with the case 2. Okay, so in the case 2, the fourth solid sphere. So this is the case 2. Case 2, this is my solid non-conducting solid non-conducting sphere, solid non-conducting charged sphere. ओके, सो फर्स्ट में हम निकालेंगे आउटसाइड द सरफेस, outside the surface, outside the surface. Okay, so outside the surface, again it is small r is greater than your capital R. See, let this be my sphere. This is my sphere, and you see this is my sphere. This is a solid sphere. This is a solid sphere. A solid sphere, and we are considering uniform distribution of charge, the easiest case. Okay, so plus 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 plus, it is uniformly, the charge is uniformly distributed. So charge can be of negative also, it can be negative charge also. Okay, we are considering positive charge. Okay, for that the electric field lines will be directed towards the body. Okay, towards the body. Now here the electric field will be radially outward, radially outward. The positive charged body will be considered, then the electric field will be radially outward. So this is the uniform distribution of charge. The total charge is uniformly distributed throughout the body. That's why it is a mu case. Okay, so now let the radius be capital R, radius be capital R, but we are going to find out electric field intensity at an outside point. Okay, this P is an outside point where we are going to find out the electric field intensity. Okay, at this point, this is the outside point. So now draw a spherical Gaussian surface. Now draw a spherical Gaussian surface. Okay, now draw a spherical Gaussian surface. Now, so this is my spherical Gaussian surface. Okay, so this is my spherical Gaussian surface. Gaussian surface. So purely imaginary. You know, spherical Gaussian surface is an imaginary surface. So now again consider a small sphere over here, a small surface over here, small surface, a small portion of the Gaussian surface. So it is represented by radially outward normal. Okay, so this is my ds vector, this is my ds vector, and you know electric field is again radially outward. So now applying or using Gauss's law, which is integration over closed loop E dot ds, which is nothing but the total electric flux linked with the closed surface, that will be equal to 1 upon epsilon naught times the total charge enclosed within the closed surface. So this is the statement, and this is the mathematical expression of Gauss's law. So this is the total electric flux, okay, is equal to 1 divided by epsilon naught times the total charge enclosed within the closed surface. Now we are going to open this integration over closed surface. It is E A dot B is equal to AB cos theta. So E dot ds will be equal to E ds cos theta. You see the direction of E is along the direction of ds itself. That's why theta will be equal to 0. So cos theta will be equal to 1. So cos theta is equal to Q in divided by epsilon naught. And you see E, the magnitude of electric field intensity. This is the magnitude of the electric field intensity, which is constant everywhere on this Gaussian surface, because it is the distance is r. The distance is r everywhere. The radius of the Gaussian surface, small r, is a constant quantity. That's why E will be constant. Okay, the magnitude of the electric field, although the direction is different, the direction is radially outward, so direction is different at different points of the surface, but the magnitude is the same, so E can be taken out because it is the magnitude. So integration over ds, cos theta becomes 1 because theta is equal to 0 degree. So limiting value runs from 0 to 4 pi r square, okay, will be equal to q in. You tell me, what is q in? You see, the total charge, you see, the total charge is within the Gaussian surface. That's why q in will be equal to q will be equal to q. आप देख सकते हैं टोटल चार्ज, बड़ी टोटल बॉडी is inside the Gaussian surface. Okay, that's why the q in will be equal to q, the charge on the surface. Okay, so that is q divided by epsilon naught. Q divided by epsilon naught. Now integrate. So ds integration, it is s. So limiting value runs from 4 pi 0 to 4 pi r square. So it is q divided by epsilon naught. So E multiplied by 4 pi r square minus 0 is equal to q divided by epsilon naught. So this implies E outside will be equal to this 4 pi r square goes to that side and becomes 1 divided by 4 pi epsilon naught q divided by r square. Now again you can watch, again you can see, you see. So outside the surface the value is again 1 divided by 4 pi epsilon naught q divided by r square. So पिछले वीडियो में, लास्ट वीडियो में हम जो 3 केसेस कंसिडर किए थे, होलो कंडक्टिंग, होलो नॉन कंडक्टिंग एंड सॉलिड कंडक्टिंग, ये तीनों केस में भी आउटसाइड के लिए वही एक्सप्रेशन हमको मिला था. ये एक्सप्रेशन है इधर. ओके, सो E outside, you see the same expression we have obtained. So चारों केस के लिए हमारा E outside is same. Over here also you can tell the body, the extended charged body will behave like a point charge for an outside point. So for an outside point, this sphere will behave like a point charge as if the total charge is concentrated at its center. Okay, so outside के लिए क्लियर है. So now we are going to deal with the second case, that is on the surface. So surface के लिए r equal to r. So again you see, so E surface will be equal to 1 divided by 4 pi epsilon naught q divided by this small r will be replaced by capital R. So सरफेस के लिए देखो, ये P पॉइंट को सरफेस में ले आओ, देखो कैपिटल R स्मॉल r सेम, so it is capital R square. तो देखो सरफेस का वैल्यू भी उतना ही है पिछले तीनों केस में जितने निकला था. ओके, सो सेम. सो देखते हैं इनसाइड क्या होता है, अंदर क्या होता है. So please note it down. Let me erase this portion. तो स्फीयर का अंदर हम घुसेंगे, देखते हैं इलेक्ट्रिक फील्ड इंटेंसिटी इनसाइड कितना आता है. चलो देखो, Now the case will be interesting. This case is now interesting because there will be something new we are going to find out. You see, please watch carefully. So this is थोड़ा बड़ा करके दिखते हैं. So this is the sphere. Okay. The total charge is uniformly distributed throughout the body. The total charge is uniformly distributed throughout the body. Uniformly distributed throughout the body. Let the total charge be Q. This is the center. Okay. This is the radius. This is the radius capital R. And we are going to find out electric field intensity at a point P, which is inside the surface. Okay. So again, we are going to draw a Gaussian surface. So this is my spherical Gaussian surface, which is inside the surface of the sphere itself. Okay. So this is my Gaussian surface. So spherical Gaussian surface. So spherical Gaussian surface. Now we are going to apply the Gauss's law. Using Gauss's law. Tell me, what is this? So integration, the mathematical expression E dot ds will be equal to 1 upon epsilon naught times the total charge enclosed within the closed surface. Closed surface is our Gaussian, spherical Gaussian surface. Okay. चलो आगे बढ़ते हैं. देखो क्या होता है. So integration over closed surface E ds, again cos 0, you see. So this is my ds, okay, outward normal, and is again radially outward. So theta is equal to again 0 degree. So cos theta becomes 1 again. No change up to this, no change. Okay, mark the change we are going to face. So 1 divided by epsilon naught times q in C. This is my Gaussian surface. ये मेरा Gaussian surface है. ये बॉडी का जो पूरा चार्ज Gaussian surface के अंदर है क्या? No, because some charge resides outside the Gaussian surface. So Gaussian surface के अंदर इतना ही चार्ज है. ये जो स्फीयर है ना, ये स्फीयर, ये जो स्फेरिकल गॉसियन सरफेस, ये स्फेरिकल गॉसियन सरफेस के अंदर कुछ चार्ज है. इसको मानते हैं Q प्राइम. लेट Q प्राइम बी द चार्ज इनसाइड द गॉसियन सरफेस व्हिच विल बी आवर Q इन. The total charge is not inside the spherical Gaussian surface. Please keep in mind. This is the turning point. This is the point to be understood. This is the critical point. Okay. So this is my Q prime. You see. So Q in will be equal to Q prime, not Q. Q prime. Q in equal to Q prime. This Q prime is the charge within the spherical Gaussian surface. Clear to all of you? इसको हम निकालेंगे, इधर सब्स्टिट्यूट करेंगे, so that we will get the electric field intensity. So this is the turning point. Okay, this is the point to be understood. Please careful. So E is constant quantity. Okay, E is the magnitude of electric field intensity is constant everywhere on the surface. So E is taken out of the integration. So 0 to 4 pi r square limiting value to ds. Cos 0 becomes 1. Okay, cos 0 becomes 1. So is equal to Q dash divided by epsilon naught. So this implies E multiplied by, directly we can substitute. So ds का integration s, limiting value from 0 to 4 pi r square. So 4 pi r square minus 0, it is 4 pi r square is equal to q prime divided by 4 pi epsilon naught. Now E will be equal to, so E will be equal to q dash divided by 4 pi epsilon naught times r square. R square. So 4 pi r square goes that side to the denominator. Sorry. So this is only epsilon naught. Sorry. So this is q dash divided by epsilon naught. Okay. Now in this step, this 4 pi r square goes to the denominator of RHS. So E will be equal to q prime divided by 4 pi epsilon naught r square. So now हमको q डैश निकालना पड़ेगा. तो कैसे निकालते हैं? चलो आओ निकालते हैं. So now come over here. Let the volume charge distribution. Let total charge. Total charge. You tell me the total charge. Total charge on the body is equal to q. Total charge on the body will be equal to q. Okay. And radius of the body, tell me. Radius of the body is equal to capital R. Tell me the volume. Volume of the body is equal to 4 by 3 pi r cube. The volume of the solid sphere. The volume of the solid sphere is 4 by 3 pi r cube. देखते हैं. सो मैं ये सब क्यों करता हूं? देखो मेरा लक्ष्य है क्यों प्राइम निकालना है. द चार्ज विद इन द स्फेरिकल गॉसियन सरफेस ये निकालने में जा रहा हूं. तो कैसे निकालता हूं? देखो. सो चार्ज, टोटल चार्ज, पूरा होल स्फीयर का टोटल चार्ज क्यू है. इसका रेडियस कैपिटल आर, वॉल्यूम 4 by 3 pi r क्यू. टेल मी द वॉल्यूम चार्ज डिस्ट्रीब्यूशन. वॉल्यूम चार्ज डेंसिटी. टेल मी volume charge density. So volume charge density is equal to charge per unit volume, which is represented by rho. You know. So linear charge density lambda, surface charge density sigma, and volume charge density rho. So this is my charge per unit volume. So charge, total charge q divided by volume 4 by 3 pi r cube. Okay, so this is my volume charge density. So unit volume में इतना चार्ज है रो, वॉल्यूम चार्ज डेंसिटी. ओके, 4 by 3 pi r क्यू वॉल्यूम में क्यू चार्ज है. तो यूनिट वॉल्यूम में कितना चार्ज है? क्यू डिवाइड बाई 4 by 3 pi r क्यू. इट इज रिप्रेजेंटेड बाई रो. नाउ ओके, कम टू ओके, चलो ओवर निकालते हैं. टेल मी द वॉल्यूम ऑफ स्फेरिकल गॉसियन सरफेस. टेल मी द वॉल्यूम ऑफ द स्फेरिकल गॉसियन सरफेस. बताओ कितना है? इज इक्वल टू 4 by 3 pi स्मॉल r क्यूब. ये पूरा बड़ा स्फीयर का रेडियस है कैपिटल आर. इसका वॉल्यूम है 4 by 3 pi r क्यूब. बट व्हाट इज द वॉल्यूम ऑफ द स्फेरिकल गॉसियन सरफेस? इट इज 4 by 3 pi स्मॉल r क्यूब. दिस इज द स्मॉल r. दिस इज स्मॉल r. द पॉइंट P is inside the surface, which is at a distance of small r from the center of the sphere. So ये गॉसियन सरफेस का वॉल्यूम है 4 by 3 pi r क्यूब. तो बताओ यूनिट वॉल्यूम में अगर रो चार्ज है, यूनिट वॉल्यूम में अगर रो चार्ज है, तो 4 by 3 pi r क्यूब वॉल्यूम में कितना चार्ज होगा? वही तो मेरा होगा. सो चार्ज inside the Gaussian surface. So that is my Q prime. Q prime is equal to rho, charge per unit volume, multiplied by volume of the Gaussian surface. It is 4/3 pi r cube. यूनिट वॉल्यूम में रो चार्ज है, तो इतना वॉल्यूम में कितना चार्ज होगा, तो मल्टीप्लाई होगा कि नहीं. सो दिस इज माई क्यू प्राइम. ओके, नाउ कम ओवर हियर. थोड़ा इधर मैं इरेज करता हूं. तो मेरे को क्यू प्राइम चाहिए टू फाइंड आउट द ई इनसाइड द सरफेस. सो क्यू प्राइम इज ऑलरेडी फाउंड आउट. सो क्यू प्राइम is equal to, so this implies Q prime is equal to rho. What is its value? Q divided by, so Q divided by 4/3 pi r cube. This is the value of rho, multiplied by 4/3 pi r cube. Now 4/3 cancels out, pi cancels out. So this implies Q prime is equal to Q Q r cube divided by r cube. So this is the value of Q prime. Which is my Q in. Gaussian surface के अंदर इतना चार्ज है, पूरा चार्ज नहीं है Gaussian surface के अंदर. Okay, please keep in mind. Now from this expression, now we are going to find out what is the electric field inside. So this E inside will be equal to Q prime this much. So Q r cube divided by r cube. और डिनोमिनेटर में क्या है देखो, so it is 4 pi epsilon naught r square. ओके, तो इसको मैं इरेज कर देता हूं. तो फाइनली E in will be equal to this r square cancels out. So it is 1 divided by 4 pi epsilon naught Q r divided by r cube. You see the expression. It's a very interesting expression. For the first time we have got E inside. E inside is directly proportional to R. E inside is directly proportional to the R. प्रीवियस वीडियो को वॉच करो, प्रीवियस वीडियो को देखो, मैं लिख के रखा हूं इधर. होलो कंडक्टिंग, होलो नॉन कंडक्टिंग एंड सॉलिड कंडक्टिंग के लिए E inside 0 था. क्योंकि अंदर चार्ज नहीं था. वो तीनों केस में चार्ज अंदर नहीं था, चार्ज सरफेस में था. लेकिन इधर क्या है, जो सॉलिड नॉन कंडक्टिंग केस है, इधर चार्ज इज यूनिफॉर्मली डिस्ट्रीब्यूटेड थ्रू आउट द बॉडी. तो इधर जो हमारा स्फेरिकल गॉसियन सरफेस के अंदर चार्ज है, तो इसके ये इलेक्ट्रिक फील्ड इंटेंसिटी 0 नहीं हो सकता. सो इलेक्ट्रिक फील्ड इनसाइड द सरफेस विल बी इक्वल टू 1 divided by 4 pi epsilon naught times Q r divided by r cube. 1 divided by 4 pi epsilon naught is a constant quantity. Radius of the surface, radius of the body is a constant quantity. So r varies from center to surface. So as r increases, E inside also increases. Okay, E inside is directly proportional to r. So just at the center, what is the value? सेंटर में E का वैल्यू कितना है? सेंटर में R इज इक्वल टू 0, स्मॉल r इक्वल टू 0. तो E सेंटर, यू सी, E सेंटर इट इज 0. E सेंटर 0 बिकॉज R इज इक्वल टू 0. एज R इज इक्वल टू 0, सेंटर में R इज इक्वल टू 0, दैट्स व्हाई E सेंटर विल बी इक्वल टू 0. एंड E ग्रेजुअली इंक्रीजेस एज वी अप्रोच टुवर्ड्स द सरफेस. सेंटर से जब सरफेस तक हम प्रोसीड करेंगे तो E का वैल्यू इंक्रीज करेगा. ओके, एंड सरफेस में मैक्सिमम दिस मच, सरफेस में मैक्सिमम. जब हम आउटसाइड चले जाएंगे तो फिर से E क्या करेगा? डिक्रीज करेगा, इनवर्सली प्रोपोर्शनल टू R स्क्वायर. तो चलो इधर लिख के रखते हैं. इधर देखो E इनसाइड, नाउ द एक्सप्रेशन चेंजेस. तो E inside it is 1 divided by 4 pi epsilon naught Q R divided by R cube. So this is the expression. Okay. So now finally we are going to plot a graph which explains everything about our discussion, how electric field intensity varies with distance from center to the surface and outside. See carefully. So this is my sphere. This is my sphere. Okay, where charge is uniformly distributed. Charge is uniformly distributed. Okay, let this be the center and this is the radius capital R. Okay, now we are going to plot the graph between your, this is R, distance from the center, and this is electric field intensity, and now drop a perpendicular from the surface. Okay, so this is the center, this is surface, this is outside, this is outside, and this is inside. This is inside. So here R is equal to 0, here R less than R, here R is equal to R, and here R greater than R. So these are the situations, and the expressions are over here. Now you can watch. So center में 0 है, center में देखो 0 है, R center 0, and it increases linearly. It increases linearly up to surface. So E inside is directly proportional to R. Very interesting case. E inside is directly proportional to R, and just on the surface, it becomes maximum. E surface, which is your maximum value, is equal to 1 divided by 4 pi epsilon naught Q divided by R square, and outside the surface it decreases like this. E out is inversely proportional to R square. See the graph, see the variation. So this graph explains the variation of electric field intensity with respect to your distance of the point from the center of the sphere. Clear to all of you? Clear? अगर डाउट है वीडियो को फिर से दोबारा देखो, डाउट क्लियर हो जाएगा. अगर कोई किधर डाउट डेवलप कर रहा है तो प्लीज कमेंट सेक्शन में मेरे को क्वेश्चन करो, मैं फिर से इसको एक्सप्लेन करूंगा नेक्स्ट वीडियो में. सो थैंक यू ऑल, गुड बाय.